Hello everybody and welcome to exercise 3 on page 12 of the workbook. And we're trying to integrate x squared e to the 2x dx in this problem. Okay, so let's try out the technique of integration by parts on this. If you attempted this problem, you might have noticed that it takes a little bit of trial and error maybe to lay your hands on good choices for u and dv here. One choice that will end up working for us is to make u equal to the x squared part and dv equal to the e to the 2x dx. Okay, so with those choices, we first need the derivative of u, so du is going to be 2x dx. And then the question is, what do we get for our v? Okay, so we need an antiderivative for the function e to the 2x. Okay, we know that if we were to integrate just e to the x, we would get e to the x, but there's a 2 with it. Okay, so it might be helpful to think about how a derivative would work here. If we took the derivative of e to the 2x, we would get 2e to the 2x by the chain rule. Here we're kind of going in the opposite direction, and it turns out that 1/2 e to the 2x would work. Okay, now just to reassure you, let's double check and make sure that that works. Where did that 1/2 come from? Okay, well, I'm going to sneak that in up here. If we take the derivative of the v that we just wrote down, notice what happens here. 1/2 is a constant that comes out, and then the derivative of e to the 2x by the chain rule is going to be e to the 2x times the derivative of the inside, which would be 2. And so the 2's cancel, and we get the e to the 2x that we wanted. Okay, that confirms that if we take the derivative of our v choice down here, we do get back to dv. Okay, so that 1/2 is just the number that we needed to get the 2 to cancel out. That's one way to think of it. Okay, so there are our choices for u and v. Let's see where that leads us. So if we write down the integration by parts formula, we're going to get u times v. We take u and v and multiply them together. We'll get 1/2 x squared e to the 2x. I've written those terms in a little bit different of an order, but that's okay. And minus the integral of v du. Let's see, v is 1/2 e to the 2x, and du is 2x dx. Okay, we get a little cancellation here, so those 2's go away. And let's see what we've got here. 1/2 x squared e to the 2x minus, after we simplified, the integral of x e to the 2x. Okay, so to finish this problem, we need to integrate x e to the 2x. Can we do that? Okay, well, that integral is not quite simple enough to do directly because of that extra x term that's there, but I would like you to notice that it is simpler than the integral that we started with. So we started with an integral that had an x squared in it, and we worked it down to an integral that just has an x in it. That's a good sign that we've made some progress here. All right, so to do this integral, we actually need to repeat integration by parts one more time here. Okay, so this is kind of a long problem. So we're going to take this integral and use integration by parts again. Okay, so for that integral, what would be a good choice for u and dv in this case? We maybe use the same idea that we did before and make u equal to x and dv equal to e to the 2x. That type of a choice worked for us before. And so let's see, if u is equal to x, then du is just going to be 1 dx, which we can just write as dx. And we already know from up here that if we make a choice for dv to be e to the 2x dx, take its antiderivative, and you're going to get 1/2 e to the 2x. That's exactly the same calculation again. Okay, good. So there's the u and the v that go with our new integral, so continuing. I'm going to put a big set of brackets because what we're going to write down is the integration by parts formula for this integral that we're boxing in. The minus sign that's in front applies to that entire integral, so we need brackets here. And inside the brackets, we're going to get uv. Okay, over here to the right, we can see what our u and our v are. So uv, if you multiply all those together, you're going to get 1/2 x times e to the 2x minus the integral of v du. This time v is 1/2 e to the 2x, and du is just dx. Okay, so there's what we've got. Okay, so let's rewrite some of this. So we'll take that 1/2 sign and distribute it through. Notice that this minus sign is also going to apply to that other minus sign. You put those together and they cancel, and we get a plus 1/2 e to the 2x. Okay, now we're almost there. So notice that there's a 1/2 that we can actually pull outside of our integral. Just so that I don't have to write all of this again, I'm going to take that 1/2 and just move it to the outside immediately, like that. Okay, and what it comes down to is, can we integrate e to the 2x? Well, we actually did that a couple of times. That's the same calculation that we did up here. When we went from dv to v, we discovered that the integral of e to the 2x is 1/2 e to the 2x, and that's going to be the same down here. So if we rewrite the part that we're done with here, we integrate e to the 2x, and again, we're going to get 1/2 e to the 2x plus c. Okay, I'm doing a lot of writing here. You might figure out a shorter way to write all of this down. Okay, but I want to write one more step and put those two 1/2s together to be a 1/4. Okay, and we've done everything right. That should be our answer. There is our antiderivative, and notice again that we used integration by parts twice in this problem to come up with our antiderivative.